So welcome to our Think Together video podcast. Today I'm hosting a discussion on printed electronics used for e-mobility, used in e-mobility applications. My name is Aart van der Spuy. I'm responsible for business development, Henkel Printed Electronics in Europe. I have a background in electronics and also automotive electronics, and that's how I also got involved in some real nice applications of battery management. And I'm happy to have Florian Ulrich today as a discussion partner of InnovationLab to talk about battery monitoring. So I hand over to Florian for a quick introduction.
Thank you, Ed. It's a pleasure to be here. My name is Florian. I'm responsible for business development at InnovationLab. From my background, I'm a physicist and also have experience in material science. And after finishing my PhD at the location of InnovationLab, I switched into the business development, and one of my tasks there was also the development and bringing to the market of our battery monitoring solution. It's a pleasure to be here. Thank you for having me.
Great. So yeah, well, we're going to talk about battery monitoring and talking about e-vehicles. I'm driving an electric car myself, and one of the challenges I think is still the battery system. So the battery performance, I was wondering when I started to look for electric cars, what would be the range and how would that range be in a few years? So I think still it's a concern or maybe a challenge to look at the performance of the battery. How will it look like and how to finally then monitor it on the battery life, and also maybe to have better designs of a battery, how to improve the battery technology, because again, it's a key component for an e-vehicle. I was really excited to see that InnovationLab developed quite an interesting sensor to monitor the battery. And Florian, I think you can, you can talk about it and elaborate it on how it works. So how printed electronics plays a role with printed sensors. So,
yes. So of course, the range, I think the range of electric vehicles is one of the key factors. Everyone that is using an electric vehicle knows that you have to stop every now and then, and improving and prolonging this range is one of the major aspects to make this technology more usable. And for this, of course, the battery pack, the functionality of the batteries themselves, and also the cells and the interconnection between the functionalities of each cells is crucial. And there has been a lot of improvement, and there will also be a lot of improvement for the future. But what we have realized is that there is a lack of information on cell level. So this is basically impossible to get a lot of data from the cells themselves. So one thing is the cell level, and then also the sub-cell level. So the how is physical parameters distributed over each individual cells. And this is data that is more or less impossible to get with conventional systems. And we have identified this gap, and we have developed a solution together with an OEM who is actually the expert in this type of technology. And with this technology, you can get such data from the inside of the battery, and this helps you to understand how a battery and the cells are actually working. And this knowledge is crucial and is actually necessary for further improvement of the battery packs. So maybe first of all, we're not all experts here. So you have the cells, you have the individual cells. This could be pouch cells, for example. Similar to batteries that are also in mobile phones, for example. And for electric vehicles, they are stacked together. So you have several cells next to each other, and they are combined to a so-called module. And several modules are combined together in one pack, and you have then one pack in your car. And while the cells themselves are actually pretty well characterized, there's still room for improvement, especially room for improvement for the interplay, because then you have, for example, effects of heat transfer. So when you use batteries, of course, there's a heat increase or a dissipation, and this will flow somehow through the battery and affect the performance of the cells. So this is the main message. We provide with our solution data from the inside of a battery for the possibility for improvement. So it is really an R&D solution, but I will talk about this later on. I think for now, you're also interested how this looks like and how we realize it. And
how does it work? So what are we looking at? So we're looking at an area of the battery within the battery, I assume.
Yes, so this is totally correct. So we have sensors in the battery, and that enable the spatial resolution, and this is what you see here. So there's a color-coded spatial resolution of the pressure. And when we have a look at the video, you see how this pressure distribution is changing over time. And when you integrate the signal of each of these individual pixels you see here, then you get this global signal, which is at the bottom, and it goes up and down. And this is what you call so-called breathing of a battery. And it comes from the fact that when you charge a battery, it will expand. And when you decharge or uncharge it, it will shrink again. So when you have a fixed housing, then also the pressure will change accordingly. And this is what you see here. And this is actually a very important parameter, because also for the pressure, there's what they call sweet spot for the performance. And you would like to have your battery always at the best, at this sweet spot.
Okay, so what we are looking at is then a printed sensor in a way.
This is correct, yeah.
And it has a certain well, how does the surface look like? Is it like I think it's in an array in a pixel way, so that you can measure or yeah, follow the pressure on a pixel level, I would say.
Yes. Yes. Let's have a yeah. Let's have a look at the foil sensor itself. The foil sensor is very crucial because this is the difference to conventional technology, where you always have a huge thickness. It's just impossible to have such a solution until now with foil sensor technology. With foils, we have thicknesses of around 25 to 100 microns. And so therefore you can place these foils in between the cells I have just mentioned before within a module. And what you see here is stripes. On the other side, you have stripes as well. They are oriented perpendicular to each other. And like this, you get kind of a grid. Yeah. And at each of these junction points, there's a special ink with a force-sensitive resistance. So when you press it, then also the resistance changes. And when you apply a certain voltage, of course, you can measure the current, and with that the resistance, and with that the pressure at each of these points.
Great, yeah, that's good to see then how to use our inks in this kind of application. So yeah, talking a little bit about the ink, it's yeah, what you can see here. So the black spots that's made with our carbon inks, and these carbon inks for force sensing are typically then carbon inks that you can blend to a certain resistance level, and from there you can start to design a force sensing force sensing sheet, so a sensor that can measure force in a way. What's also, because within Henkel we do a lot of work within the thermal management of the battery, so like temperature is also very key on the performance, because when a battery is getting overheated, also the performance is going down, I think. Because what I've learned is that you can also integrate some temperature sensing there.
Yes, this is correct. So we also have foils for measuring the temperature, and not only the temperature at single spots, but similarly to what you see here, the temperature distribution over the cell level. And this is luckily with very similar ink. So we have also, of course, conductive silver inks and carbon-based ink. And with that, we get sensors with a resolution of 1 Kelvin and better. So this is very good and also sufficient, as we are informed from our experts, from the battery experts. And we can measure over a huge range between, at least between 20 and 100 degrees C. We did already perform measurements like at minus 10 degree. And with that, you get a temperature distribution. And these are key, these two parameters are key parameters, the pressure and the temperature. And as the foils are so thin, you can have these foils next to each other between two cells and have both parameters at the same spot. So this is the current solution where we have two different foils for pressure and temperature. But in the next iteration, there will also be foils that measure both of these parameters at one single printed foil.
Yeah, that was my question. So you can combine the functionalities in one foil sensor, and that, yes, again, that's the beauty of printed electronics and printing with printed electronics, that you can combine different functionalities. But of course, yes, the InnovationLab solution is, of course, I'm very happy that our inks are used for the sensor. But I think it's the total solution, right? It's the how to get these signals coming from the printed sensor translated to to signals and generate data. That's finally is what this solution is about.
Yeah, correct. So the sensing part is one thing, takes some development, of course, but I would say the core technology here for making use of these foils is in the readout electronics. The readout electronics is hidden in the slide you see here, in this gray box.
The box. Yeah.
Yeah. And this is a dedicated developed electronics by InnovationLab. And the main feature of that, what I would say, is the so-called crosstalk-less functionality, because you have a passive matrix here, and we multiplex through the lines and columns to address the individual pixels. But as you do so, you typically not address only each single pixel, because you have leakage currents, and they distribute and inhibit your make your signal worse. So you have influences that you don't want to have there. And we encountered this with the dedicated electronic system, and now this has this crosstalk-less functionality, and this is the condition for having quantitative measurements, actually.
Okay. Yeah. And this sensor today is used in like in R&D environment, I think, and also it's a big help for OEMs and battery manufacturers and battery designers to improve the design, I think. So that's what it's about. But finally, you could also think of, well, maybe having a sensor then in my next generation car that could have the capability to continuously monitor the battery health or the battery performance, and then also adapt the charging maybe to it. So
this is totally correct. So the solution is designed for R&D purposes, and since we have launched the product in last December, we got a lot of requests with basically all the big OEMs, and we're in close contact and also selling the solution first in a standard version. Then also the customers have the possibility to buy customized solutions and get the information for their research and the improvement of the batteries itself. But as you said correctly, the next generation will go into the car. However, you cannot put it into the car in the way you see it here. Simply because the readout electronics is way too powerful. It would generate way too much data. So this is not really necessary, useful, and also not be able to being paid within the car industry. And therefore, the next generation will have way less pixels, also more distributed over the whole battery pack, and dedicated electronics. And then the system will talk with the BMS, so the battery management system.
Yeah. Okay. So the sensor finally, if it really comes to the final car, so to the series, will look then a little bit less complicated or simpler, and also then you will be able to produce these kind of sensor on a larger scale, I think. So what is the process today? How these are our inks processed? It's a screen printing process, I assume.
This is mainly a screen printing process, but we already go also on our roll-to-roll machine for the production of these samples. And here we have a combination of screen printing and flexo printing. And when we go to the series, of course, then we will only use our roll-to-roll machine. Actually, one of our two roll-to-roll machines, because they have such a high throughput, and with that, it is possible to reach very, very low levels of price as compared to the more manual screen printing process in sheet to sheet.
Great, yeah. So we all know that the automotive industry is very price sensitive. So
yeah,
finally, you were also able then to have high volume production at much lower cost than cost than this R&D tool.
Yeah. So maybe it is worth at this point to also discuss our collaboration here, how we would handle such a high volume manufacturing. So we as InnovationLab, we basically provide development services, sensor development, and also prototyping and upscaling on our roll-to-roll machine. But for really high volumes, then we transfer this technology and the process know-how to our partners of Heidelberg printing, Heidelberg Printed Electronics or Heidelberg printing machines. For those of you that are not aware of this fact, Heidelberg actually produces printing machines, right? So they are one of the main producers worldwide. But in the field of printed electronics, they focus on the manufacturing of the components. And this is where we work together.
Great. And yeah, talking about e-mobility and talking about the battery, I can think of more applications around or in e-mobility. Also, what could be very important for a battery system is the water ingress, I think. Can you think of other like surface conditioning monitoring, so using printed sensors in battery systems or power electronics, or actually in the powertrain of an e-vehicle? I think there are more possibilities for printed electronics. What's your view on that?
Yeah, so there are several applications indeed. One thing is, of course, as you said, the possibility to integrate further sensors, like for example, humidity sensors. This is for sure, or also gas sensors for outgassing, detecting this early, and so on. But there's also not only the possibility to print sensors with electronics, but also other features, like for example, heaters or flex PCBs. When we stay for the heaters, because of the topic of thermal management, of course, when you measure the temperature, you may also like to adjust the temperature. And this can be done with printed foil sensors. They can be similarly integrated into the battery pack and adjust the temperature when it's necessary. This is one very important thing, and where we also get good feedback from the experts, because I mean, we are providing the technology solution. We are not the experts in battery management and battery design. And the second topic that you mentioned is PCB and wiring, and flex PCB, flex FPC, because there, of course, you have a lot of current and power and also signals that flow from A to B. And for this, currently are used etched coppers on polyimide base. And this has several drawbacks. One is, of course, the material consumption for this, and the huge potential waste that you have. And the other one is, even though it is pretty cheap because it's a well-known technology, it can be done even cheaper with printed electronics, especially when you have this large sizes of, let's say, 0.5 meter or a meter. Then it gets quite expensive with the conventional technology. So this is the wiring and the connection, and then also to close this loop to flex PCBs. Everybody knows PCBs, I think, the green things that you have in every electronic device. Also here, this is a very, very standardized and well-known technology, but still when you print conductive and solderable traces onto foils, then you can reduce the price here even more.
Great. So still enough room for printed electronics in the automotive industry and in e-mobility, I would say.
Definitely.
I think it's a very interesting application. I would like to thank you very much for your explanation on this very innovative system.
Pleasure.
Of battery monitoring. And I think, yeah, if our viewers would like to contact us, the contact details are on the screen right now. So very happy to get in touch with, for me, of course, to talk about the inks and what our inks can do for printed electronics and printed sensors. And of course, for the final solution, I think it's InnovationLab.
Thank you very much.
Thank you, Florian.